All right, so now that we've gone over what a t-test and an ANOVA really is, let's go through and see how to conduct these using Stats IQ. Okay, so for the first part of this assignment, question one, you're looking at, so if gender was an input variable, what potential output variables would you need to run a t-test and ANOVA? So think, okay, in what instances are we going to run a t-test and ANOVA? If gender is your input, your output should be what? A category or a number, and then you're going to select the correct response from these based on whether they're a category or a number. So think back to our last video. Which one should it be? A hint, it should be a number. And if you want to go through some of these, say for instance, I'm not sure. Once again, like I'm not sure which variables are numbers, which ones are categories. It shows here on this side of Stats IQ. If there's a 1, 2, 3, then we're going to treat it like a number. If there's if there's lines with bullet points, we're going to treat it like a category. And if there's a bar, we're going to treat it like a category as well. And then we won't really deal with the time variables very much in this course. So those are the three that you need to worry about. A number with 1, 2, 3. Bar is a number as well, and a category are the lines with the bullet points. But if I want to know, like for instance, here, if I want to know when I need to run a t-test, which variables I would run a t-test with, and this is looking specifically at input variables, right? So if I want to know what I need to run the t-test on, I need to know how many categories are in my input. Do I have 2 categories or more than 2 categories? And think back to the last video. In what case are you running a t-test? Do you have 2 categories for your input, or are there more categories? So for instance, 2 categories would be like product color, blue and red, or gender, male and female, right? Those would be 2 categories. More than 2 is going to be product color, red, blue, yellow, green. Those would be 4 categories, very simply. Okay, so I need to think, okay, in what case am I going to run a t-test? How many categories? And to figure out quickly how many categories each of these have, you can just go through and I'll just pick a couple of categories. And I can click describe like we learned in our first session of Stats IQ. And then plop, this one has 2 categories. This one has 3 categories. This one has 2 categories. You can describe the data and very quickly see for categories how many categories are there. So now let's move on. Number 3 is asking which of the following variables are significantly predicted by gender. All right. So looking at these. First of all, you need to ask, like, okay, what's my input? Is it gender, or is it these variables? And if it's asking like if something's significantly predicted by, or influenced by, or impacted by, that's going to be your input. So gender's our input. So what I can do is come over here. I'm going to deselect these puppies. I'm going to find gender. There it is. And what I would do is I would just I would select all of these, okay? And so I'm just going to select a couple of number variables. Now, once again, if I click relate, we're going to do just like we did with chi-squared last week. We're going to analyze these with relate. If I click relate, though, in this case, it's going to run it the wrong way because remember, by default, the key represents your outcome variable. All right. So if this question is asking me to use gender as an input variable, which it is, then I would not necessarily want the key to be gender. However, in this case, it would be really nice if I could just select a bunch of outputs, right? If I could just select, okay, I want to see if it predicts any of these, which is kind of what you would want to do in this question. So what we can do is we can switch what the key represents. I'm going to click this button here, and now the key represents the input variable. and I can click relate, and then we'll kind of take a look at how to run a t-test here. So female tends to have higher values for Q5 than male, okay? So these results are going to look a little different than chi-squared. For chi-squared, our output was a category, okay? So for chi-squared, we were getting percentages and numbers. So what percentage of males completed the class? What percentage of those who purchased came back to purchase more? You know, we have these two category variables, and we're counting how many people are in each of those categories. Okay, and then we're running a p-value and doing all that with a chi-squared. In this case, though, our output is now a number. And so what we're going to get instead of counts and percentages is we're going to get averages. All right. So chi-squared, we're doing counts and percentages. T-tests and ANOVAs, it's averages. Both, though, are going to have p-values. Okay, we're pretty much always going to be looking at p-values. So I can look here. First of all, the sentence is telling us, okay, yes, it tends to be higher. If it's not significant, it's going to say something like this. No, it's not significant. So really, you could answer that question just by running this and not looking at anything else. But we got to be careful with that because the sentence really isn't giving us the full picture. But so let's look at this a little farther. So here we see that females, their average for the likelihood of buying from an influencer was 3.67, and males it was 2.85. Now this seems higher, right? But again, we need a p-value. We need to know the likelihood that this difference is due to chance. And there's a lot of things going into it. So if there's a small sample size or the responses are very spread out, this may be deceiving. It may seem like this is a pretty high difference in the average, but there's other things going on that decrease the consistency behind these numbers. If we ran the tests again, maybe it wouldn't even be the same. Maybe they tie. Maybe males would be higher, right? And so it's important to take that p-value into account. And if I can get that specific p-value by clicking here, and I see that it's 0.0449, so barely significant, barely below 0.05. And so that is significant. And just a reminder, if it's marginally significant, it means it's not quite there. It's not quite below 0.05, but it's almost there. It's below 0.1 at least. Okay, so this one's significant, and that's it for t-test. It's pretty straightforward. We can take a look at this one. Look at these averages. Okay, 4.21 for female and 4.07 in terms of Q9. If I click here, it's saying, okay, this is not significant. All right, so that's how I'd go through and do that one. And just remember, if it's not significant like this, we're going to treat it like a tie. You know, it looks like female has a higher average, but really we can't rely on that. We couldn't find any significant difference between male and female, so we're gonna treat it like a tie. Okay, so that should help you with these 5 questions. It's really straightforward. Look at the p-value. If it's significant, you do have a winner or a loser. If it's not significant, it's a tie. So let's look at ANOVAs now. ANOVAs, they're not as simple. There's a few other things that we need to take into account. So these ones are asking while testing if influencer category influences or has an impact on or predicts. Okay, so that's telling us what this is our input. It's going to ask us to analyze that for a couple of different outcomes or outputs. So what I'm going to do, I'm going to run that same one. And then I'm going to select a few different numbers, but I'm going to avoid the 2 that we have specific questions on. just so you can do it yourself. Okay, so I'm going to do that. I'm going to run these, and again, I already pressed this button, so it's swapped. So this key here represents my input. So it's going to test all of these with influencer category as my input. And if you're ever unsure, like, oh, which way did I run it? Your input's always going to be here, and this arrow is always going to be pointing to your output. Okay, I can swap these if I wanted. And now personal comment is my input, and influencer category is my output. But for this question, I'm looking at influencer category as my input, and I just ran this on all of these. So let's take a look here. So let's look at influencer category, see if it predicts personal comments. So the likelihood that they leave like a very personal comment. It looks like there is a significant relationship, okay? And I can pop here, just like the t-test, and see, okay, here's my p-value. Now, here are the averages. Now, for ANOVA, again, so with ANOVA, our input has more than 2 categories. So we don't just have male and female or micro and macro influencer. Those are some of the things that we could have run for t-test. In this case, we have 1, 2, 3, 4, 5 categories, which is why we're running an ANOVA. Now, here's a trick with ANOVA. This p-value is telling us there is a significant relationship. There's something going on here, okay? But this p-value does not tell us that all of these significantly differ from one another. So let's take, for instance, look here. So we have a beauty influencer and lifestyle creator. That's the same average, 3.53. So you can't tell me that that beauty influencer and lifestyle creator significantly differ from one another. They don't. It's an exact tie in this case, right? Not just like a statistical tie, but this is like an exact tie, even though this p-value is significant. All right, so when this p-value is significant, this is telling us that something's going on. There's a range of things here. At least one of these categories significantly differs from the others in terms of personal comment, the likelihood that they leave a personal comment, okay? So it wants us to, we really should investigate further to figure this out. And so we can do that by clicking here on the pairwise comparison statistics, just like we did with chi-squared. This output looks a little different than it did with chi-squared. I like the way the chi-squared popped it up a little bit more, but whatever. It's going to compare all categories to each other, and it doesn't want to be redundant. And so sometimes you'll get like, look here, there's only food blogger is on the left here twice, but it's also going to be on the right here twice as well. So if we're comparing food blogger to the other categories, we need to kind of look on both sides. All right. Since beauty influencer, all 4 are over here on the left, let's start with this just to kind of see what's going on here. So this top row here is looking at beauty influencer and fitness influencer, and here's a p-value. It's 0.508. So between beauty and fitness, this difference here between a 3.53 and a 2.67 on the averages, the p-value is 0.508. So there's a 50% likelihood that that difference is due to chance. It's not significant. We're not going to rely on that. We probably need more data because 5 categories is kind of a lot to have with only 65 people. So with that lower sample, it's going to make it more difficult to get significant findings. So we look down here. This is beauty and food blogger. That p-value is 0.9, okay? 90% likelihood that that is due to chance. So we're looking here at the difference between 3.53 and the food blogger is 3.57, okay? Completely makes sense. And same here with lifestyle creator, all right? So that we really can't rely on those. And if you look down this list, you see in bold here, here's a significant p-value, and that's between fitness influencer and gamer. So we look here at fitness influencer and gamer. That's the difference between 267 and 4.11. So it's like the highest and the lowest. Those two do significantly differ from one another. All right. So if I wanted to say, I want to look at food blogger for whatever reason, I want to see, okay, does it significantly differ from all of them? I look here at food blogger and gamer. We already know this because we just looked at them all over the table, but I want to walk you through this. So if we wanted to look at food blogger compared to all the others, I see food blogger here and gamer, not significant. Food blogger and lifestyle, not significant. And I could even sort here on the right now that I've done that to find the other food bloggers. Food blogger and beauty, not significant. Food blogger and fitness, not significant. All right. So in this case, it's pretty simple. We only have one significant p-value, but there, you may have a question that was like, which categories significantly differ from gamer? And so you want to look at all the gamers, and you want to compare gamer to all the other categories and see which ones significantly differ. Okay, so in this case, we know from these p-values, none of these significantly differ from one another, except for fitness influencer and gamer, right? Those are the only two there. So here's a trick. If I asked you which category was the highest, you may be tempted to say gamer. Okay, now, but the problem is, I mean, we look here at gamer. Okay, we have one here. Gamer and lifestyle, is that significant? No. Gamer and food, is that significant? No. Gamer and, we already did this, fitness influencer, that's significant. Gamer and beauty influencer, no. Okay, so 4.1, although it appears higher than the next highest, which would be 3.57, this is not a significant difference. Okay, so gamer is not significantly higher than food blogger. Therefore, gamer isn't the winner of food blogger because there's a high likelihood that that difference is due to chance. Gamer only outperformed fitness influencer. Okay, so if I asked you which one was the highest, you don't know. It was a tie between gamer, food, lifestyle, food blogger, and beauty influencer. We couldn't determine one specific winner. And the same thing goes with the loser. The only significant difference we saw was a fitness influencer was significantly lower than gamer. But fitness influencer was not significantly lower than beauty influencer or food blogger or lifestyle creator. Okay, so it didn't significantly underperform compared to those. So we don't have, we can't determine a single loser either in this case. And so that's really important to take into account. The only time you have a clear winner is if that category significantly outperforms all other categories. Otherwise, you're going to have some ties. It's like you have a four-way race, and two of the runners get an exact tie for first place, and two of the runners get an exact tie for second place. I know that that's never really going to happen, but let's say that happened. Who was the one winner? Well, you can't determine a single winner. Who was the one loser? You can't determine a single loser. We have a statistical tie for first place and a statistical tie for second or last place in that case. Same thing here. If the p-value is not significant, treat it like a tie. All right. Okay. So that's kind of how we look at ANOVAs. Let's do another one. Okay, so here we're looking at whether influencer category predicts rage typer. Influencer category as our input, pointing at our output rage typer. Now, here this is saying there's no significant relationship. Okay, let's look at the p-value. P-value is 0.1. All right, so that's kind of this is not significant. It's above 0.1 too, so it's not marginally significant. So in this case, with an ANOVA, if this p-value is not significant, there's no need to investigate further. There's no significant relationship here, so you can move on. These averages, you're not going to treat them as significant. So there's no clear winner or loser in this case as well. So let's look here at Q6, so review reader. This one, although it says it's not significant, we can look at this and it's marginally significant. So we got to watch that, okay? Just because it says it's not significant in the sentence, we need to look a little bit closer. The p-value could be 0.057 or something like that, and it would say it's not significant. But we would want to pay attention to something that does have a p-value of 0.057. That would be marginally significant. It may not be statistically significant, but it's getting really close, and that's something we would want to pay attention to. So in this case, this is marginally significant. So there's something going on here, at least marginally. Let's take a look at the pairwise comparison table to see what we have. And here, like nothing significantly differs from each other. Okay, I can just scroll down this p-value table here and see that none of these averages significantly differ. So we're good there. I want to give you just a couple more examples, some good ones. So I'm running this with an input of competitor preference instead, just to help you think through this. So there is a significant relationship with competitor preference and rage typer. So likelihood that they rage type. So here are our averages. It seems like brand A is high. The sentence says it's significant. We can click here. There's our p-value. We're good. But I don't know, for instance, if 3.5 is statistically higher than brand C with an average of 3.37. I don't know. I don't know if brand A outperformed brand B, and the likelihood they rage type, I guess. And so I click on the pairwise comparison table. Look here. Okay, it looks like my only significant p-value is right here between brand A and nom nom. So in this case, 3.50 of brand A did significantly outperform nom nom with an average of 2.3. But just like before, there's no clear winner or loser. Oh, look here, there's a p-value of 0.05. So that's marginally significant, at least, between brand C and nom nom. So nom nom at least underperformed brand A significantly, and marginally it underperformed brand C, but it didn't significantly differ from brand B. So there's still in that case there's not a clear loser because nom nom didn't underperform brand B. I guess that's let's see here, p-value of 0.147. Okay, so no clear loser. And when it comes to winners, if I look at brand A, it didn't outperform any of the variables here either. Okay, except nom nom. So we don't have a clear winner or loser. The main thing we can say is that nom nom did do worse. If say that rage typing is a good thing and we want people to rage type, whatever, then nom nom did do worse than brand A and brand marginally, at least with brand C. Let's take a look at this one. So there's no relationship between competitor preference and Q5, the likelihood that they buy influencer products. But if I click here, look at that. There's a marginally significant p-value. I would want to pay attention to that p-value. There may even be some other cases. Yeah, this one's marginal. Looking here at this one, okay, not quite marginal there. But you have two that are marginal that if you're just going off the sentence, you're going to think, oh, nothing's going on, but there could be something going on here. Let's look at the pairwise comparison tables. And it looks like we're just getting marginal difference between brand A and non-nom once again, okay? But no clear winners or losers because none of the others really significantly differ from one another. Same thing here with brand A and nom-nom. So something's kind of going on there. So yeah, I'm not quite seeing anything else from this one. Typically, yeah, not always, but typically it's in order of significance. At least like the significant ones are going to pop up on top. But yeah, so that gives you some more examples. Once again, the only time there's a clear winner with ANOVA is if the one on top significantly outperforms all other categories. And the same rule applies for losers. The only time that there's a clear loser is if that loser significantly underperforms all other categories. Okay, so I'm going to do one other example here. A lot of those, we were just having like a significant difference between two categories, and that was it. And that's not giving us the best examples to go off of. So let's look at this one. So here we have our input is repeat purchase, and our output is Q11. So the likelihood that they follow that influencer in the future. If I click here, here's our p-value. Okay, that's really significant, more significant than what we're seeing in some of those other examples. Here's some averages, but again, I don't know. Does 4.3 outperform 3.76, which would be like, do frequent buyers, are they more likely to follow an influencer in the future than occasional buyers? I don't know. I don't know based off of that. I have to go to the pairwise comparison table. And here are the p-values, okay? So a quick, easy way to do this, let's say, okay, it looks like frequent buyer, that one has the highest average. So I'm gonna look at frequent buyer. Did they outperform NA? No. Did they outperform occasional buyer? Okay, marginally, all right? And then there's just one more frequent buyer. Did they outperform first-time buyer? Yes, they did. Okay. So it looks like frequent buyer, they did outperform all categories except NA. So that's interesting. We're almost getting like a clear winner. What I might do actually, see the NA, it's not applicable in this case. There's only 7 people. If I wanted to, I could pop up here and go to filters, add a condition group. Say I want to get rid of the NA there. So then I'd click, and again, I'm just doing it here for this question. I'm not doing it all the way on the top here. I'm doing filters right here. Don't do that unless you want to filter your whole data set, okay, for all analyses that you run. That would not be fun. I'm just going to do it here for the question, okay, and for that particular analysis, okay. So if I can run a filter and say, all right, I don't want it to equal NA, so does repeat purchase say like does not equal NA? It's going to rerun that for me. And now I can look at frequent buyer, and does it outperform occasional buyer? Yes. Does frequent buyer outperform first-time buyer? Yes. Okay, so we have a clear winner. It's frequent buyer was the highest. They were the most likely to follow an influencer in the future. Now it looks like lower here is first-time buyer. That has the lowest average. So first-time buyer, they're both over on this side. Are they significant? Yes. So we have a clear loser too. First-time buyer was the lowest, significantly. All right. So that one's more straightforward. That's a more straightforward way to look at it. And it may be nice to remove a category if you don't think it's applicable, like not applicable in that case. All right. So I'll have another question in the assignment that where you're doing something like this. It might be for something like the number of engagements, but I'll have you try to figure that one out on your own, and you may end up having to take NA out as well. So other than that, I hope you have an awesome time with this assignment and that you reach out if you have any questions or if there's any complications in any way.